Let's go over two brief things. Continuity on an open interval. Open intervals, of course, is when I do not include the endpoints. Let me draw a graph. You don't have to, but I would like to draw this graph. If I want to go from A to B, but not include A and B, then I could potentially have some function that looks like this. Open circles on both of those. Now, maybe the circles are filled in, but I would not include A or B when talking about the interval. So maybe I do have a function that just keeps on going, but I would not talk about A and B in that, okay? A function is continuous on an open interval when you grab the correct color pen and finish the sentence. When f, the function, f of x, is continuous on every point in the open interval. Okay, well that was pretty straightforward. There we go. So now let's do it again. A, B, and we'll do the same thing. We'll make this one look a little bit happier though. We're going to fill those circles in. Now again, I could have these circles filled in, but in the context of talking about an open interval, it doesn't matter if they're filled in or not. With a closed interval that is continuous, they better be filled in. It's like a slightly happy face. So I have to meet one condition here. F is continuous on every point in AB. So yeah, we're good to go. Scrap piece of paper. So just looking at, I'm trying to find a corner that's not written on. So what I'm going to do is just really quickly draw from A to B, and I have some function. There we go. Is this function continuous on the open interval from A to B? No, it's broken right here. There's a jump discontinuity. You can call it a jump discontinuity. It is non-removable. It's another way of classifying it, but we have a discontinuity there. So if I wanted continuity on a closed interval, then not only do I have to have a function that is continuous, if I could spell, continuous on every point in AB, but I also have to meet two other criteria, and here they are. I need to be able to reach this point by just sliding from the right. In other words, the limit as x approaches a from the right of the function is actually equal to the value of the function. So I don't have this kind of thing where I'm talking about a closed interval, but the function looks like this. All right, we're going to go from A to B. And I'm like, hey, is this function continuous on the closed interval from A to B? I mean, we're good over here, we're good at B, but then as I'm trying to get towards A from the right, no, I'd have to jump too much. It's not going to work. And then we're also going to have to be able to do this from the other side. The limit as x approaches B from the left had better match up with the actual value of the function at